Good morning, this is Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. In the last sessions, we have discussed about solution of the linear ordinary differential equation with a constant coefficient. What is the solution of the ordinary differential equation of the form f of d into y equal to q of x? What is the solution of this differential equation? We have y equal to yc plus yp. Solution of complementary function and particular integral. Based on different types of q of x, we have different solutions. In the last sessions, we have discussed about yp. Yp is nothing but particular integral, where q of x is exponential function. Now, in the today's class, we have to discuss about the solution of linear ordinary differential equation with a constant coefficient and where q of x is either sin ax or cos ax. So, already we know that to find complementary function. What is a complementary function? Which is a solution of f of d into y equal to 0. For this solution, we have only yc, nothing but complementary function. Solution of f of d into y equal to 0 is nothing but y, which is yc, complementary function. Now, today we have to discuss about the solution of linear ordinary differential equation with the constant coefficients where q of x is sin ax or cos ax. Suppose we have f of d into y equal to q of x is a general linear ordinary differential equation with a constant coefficient. Here q of x is either sin ax or cos ax, where a is a constant which is not equal to 0. Sometimes we have 1, 2, 3 and so on. Cos ax or sin ax, we have only two trigonometric functions. One is sin ax, another one is cos ax. Here a must be not equal to 0. Go for the method. So here we have two cases how to find the particular integral where q of x is sin ax or cos ax. So already know how to find a complementary function. Now we have to discuss only to find particular integral. But for particular integral we can find by using only q of x. Here q of x is sin ax or cos ax. Here a must be a constant which is not equal to 0. Now what is case 1 and how we can solve this q of x where sin ax or cos ax? Suppose f of d, we have f of d, nothing but operator form of the given differential equation. Substitute in place of d square minus a square. What is minus a square? Here we have to remember one thing which is not minus a whole square. This is only minus a square. A is a constant, that is a coefficient of x, either sin ax or cos ax. We have same method if it is either sin ax or cos ax. So substitute wherever in the operator form, substitute in place of d square simply minus a square. A is a constant, d square we have like a polynomial equation like a d square plus 2d plus 1. In place of d square substitute minus a square. So sometimes which is not equal to 0, sometimes which is equal to 0. First of all write the yp. Yp is here nothing but 1 by f of d into sin ax or cos ax. Substitute in place of d square minus a square. Sometimes which is equal to 0, sometimes which is not equal to 0. So if it is not equal to 0, no problem. Substitute directly in place of d square minus a square. Then which is not equal to 0. Then we can proceed as usual. Case 2. If f of minus a square equal to 0, then write the factors of f of d. We have factors. So what are the factors of f of d, which is a second degree polynomial or third degree polynomial, whatever it is? First take the factors of the denominator. So the factors are like this: d square plus a square into some function of d. So here two fractions and one fraction is equal to 0 and another fraction is which is not equal to 0. So substitute in place of d squared minus a squared. The first term becomes 0 and the second term which is not equal to 0. Substitute directly in place of d squared minus a square in the second term and in the first term which is equal to 0. So in these cases we have direct two formulas. When q of x is sin ax by f of d is here nothing but sin ax by d square plus a square into phi of d square. In this case, if we take d square equal to minus a square, the denominator become 0. So which is not valid. The case fails. So we have direct formula, that is minus x by 2a cos ax. This is the general formula we have to remember. If sin ax by f of d square, if suppose denominator value is equal to 0, we have direct formula minus x by 2a cos ax. Suppose in place of sin ax we have cos ax by f of d, we have x by 2a sin ax. This is the case 2. Case 1 is nothing but substitute whatever it is in the denominator. In place of d square we place minus a square. If it is not equal to 0, we have to proceed same. And in the case 2, if suppose denominator value is equal to 0, then we have direct formulas. If it is sine, we have minus x by 2a cos x. X is the quotient and minus x cos ax by 2a. A is the quotient of sine or cos. And the next term cos ax by f of d. F of d again polynomial equation. So if we take d square equal to minus a square, suppose the denominator becomes 0. In that cases we have direct formula, that is x by 2a sin x. Here we have to remember two things. Sometimes we have phi of minus a square, sometimes we don't get phi of minus a square. We have only one term, suppose d square plus a square, which is equal to 0. So no need to worry about this phi of d square. So based on the given differential equation, we have factor, and based on the factor form of the given differential equation, we have the solution sin ax by f of d, which is minus x by 2a cos ax, and if it is cos, we have x by 2a sin ax. So now next we have problem, that is d square plus 9 into y equal to cos 3x. Now this is of the form f of d into y equal to q of x. This is a complete differential equation with the operator form. Why which is operator form? The given equation in terms of capital D only. D square plus 9 into y equal to q of x. So for any differential equation we have general solution. What is the general solution of this equation? Y equal to yc plus yp. Yc is nothing but complementary function. This we find by using roots of the f of d, and yp based on this q of x. Now in this session we have discussed only sin ax or cos ax in place of q of x. So first go for the complementary function. Especially complementary function alone which is not a solution, and particular integral alone which is not a solution. Both the complementary function and particular integral combined is nothing but general solution of given differential equation with a constant coefficient with any order. So now first write the auxiliary equation of the given differential equation. So in the last session already we have discussed what about the auxiliary equation. What is the auxiliary equation? Whatever the operator form in the given differential equation, in place of d substitute m. M is nothing but some variable. In place of d just replace m. So nothing but m square plus 9 equal to 0. Here f of d is nothing but d square plus 9, which is only f of d. F of d is nothing but d square plus 9. Now the auxiliary equation is m square plus 9. So now if we solve this equation, we get two roots. Why we get only two roots? Here the order of the polynomial is nothing but 2. So m square plus 9 2. 2 is the order of the polynomial equation. So definitely we get 2 roots. The roots are here plus or minus 3i. These roots are nothing but complex roots. Alpha plus or minus I beta form. Alpha is a real, beta is a real. The combination of alpha plus or minus I beta is nothing but complex number. So already we know that complementary function where the roots are complex numbers. What is the complementary function? E power alpha x. Here alpha is nothing but 0. There is no term in place of alpha. So we consider it as 0. So the complementary function is nothing but e power 0x into c1 cos beta x. Beta is nothing but here 3. c1 cos 3x plus c2 sin 3x. So e power 0x nothing but 1. So we have complementary function is c1 cos 3x plus c2 sin 3x. E power alpha is 0 here. That's why we have c1 cos 3x plus c2 sin 3x, which is nothing but complementary function. We denote this as yc, complementary function, which is the first solution. Now next we have to find yp. Yp is nothing but particular integral. So how we can find particular integral? In any case, in any form of q of x, we have yp is nothing but 1 by f of d into q of x. What is q of x and what is f of d? F of d is nothing but operator form of the given differential equation, and the q of x is sin x or cos x in this case. So yp is same for everything. Yp is nothing but particular integral 1 by f of d into q of x. Here q of x is cos 3x. So take the form cos 3x by f of d. d is nothing but d square plus 9. So if either sin ax or cos ax, we follow only same method. So here a is nothing but 3. And what is the case here? If q of x is either sin ax or cos ax, we have to replace d square equal to minus a square. What is minus a square? Here a is 3 and minus a square is nothing but minus 9. In place of d square, now replace minus 9. So if we take in place of d square minus 9, what is the general solution? Cos 3x by in place of d square, if we take minus 9, the denominator become 0. So the case fails. So if denominator is equal to 0, we have direct formula. So cos ax by f of d, where f of minus a square equal to 0, we have formula. What is that? X by 2a sin ax. What is a here? 3. So x by 2 into a nothing but 3 into sin 3x. So we have x by 2a nothing but 3, 2 3 is 6, sin x is nothing but sin 3x. So here we got the denominator value is equal to 0 and there is no another factor. We given differential equation is only second order differential equation and there is no d term also. So denominator becomes 0 completely. That's why we substitute direct formula, that is x by 2a. If it is sin, we have cos. If it is cos, we have sin. Sin ax. This is the standard form where the denominator value become 0. Now this is yp, particular integral. Now the general solution become y equal to yc plus yp. Yc based on complementary function we find and yp based on q of x. So both yc and yp will give complete solution of the given differential equation. Y is nothing but yc. What is yc? Already, which is here c1 cos 3x plus c2 sin 3x plus what is yp? X by 6 sin 3x. The general solution of the given differential equation is nothing but y equal to c1 cos ax plus c2 sin ax plus x by 6 sin 3x. which is the complete solution of the given differential equation. Go for the next problem. Here we have y double dash plus 4y dash plus 4y equal to 4 cos x plus 3 sin x. And here we have some given initial conditions. If any problem having initial conditions means finally we have to remove the arbitrary constants c1 and c2. So everything is same. First we have to calculate yc and next we have to find yp, particular integral, and add both yc and yp, and after that we have to use the initial conditions and find the complete solution of the given differential equation. So here the given differential equation having y double dash in terms of y double dash, y dash and so on. Whatever that we have to take that into operator form. Here the operator form of the given differential equation is d square plus 4d plus 4 equal to 0. So this is like f of d into y equal to q of x. Here also we have independent terms like both sine and cos having. So in any either sine or cos we have to follow same procedure. So m square plus 4n plus 4 equal to 0. Now forget yc, we should know roots of the given polynomial equation. What is a polynomial here? M square plus 4n plus 4 equal to 0. So if we solve this, we get n plus 2 whole square equal to 0. The roots are here minus 2 and minus 2. This is also second degree polynomial equation. If we solve the second degree polynomial equation, we get two roots. The roots are here m equal to minus 2 and minus 2. Here the roots are real and distinct. Real and distinct. Here the roots are real and distinct. The complementary function yc is nothing but c1 plus c2x into e power minus 2x. If roots are any time, if roots are repeated, we have to take c1 plus c2x. For one root, we have to write c1 plus c2x. So no need to write c1 e power minus 2x plus c2 e power minus 2x, which is not a valid yc. So if any root repeated 2 times or 3 times or any times, we have to take yc equal to c1 plus c2x. If one more time repeats, c3x square we will write. So in this we have only one root repeated 2 times. So we will write c1 plus c2x into e power minus 2x. This is the complementary function and which is yc. First solution of the general solution of this differential equation f of d into y equal to q of x. That is y equal to yc plus yp. Y equal to yc plus yp. In this yc is the complementary function and yp is the particular integral. Now we find only yc, complementary function. Now go for yp. Yp is nothing but particular integral. Now particular integral we find by using q of x. Here we have q of x 4 cos x plus 3 sin x. So what is the formula to take yp? Yp is nothing but 1 by f of d into q of x. What is q of x? 4 cos x plus 3 sin x divided by f of d. What is f of d? D square plus 4d plus 4. So in place of d square, first replace minus a square in cos term or sin term. In both the cases, we have a equal to 1. Sin ax plus our cos ax, a is nothing but in both the cases 1. Substitute d square equal to minus a square. Minus a square is nothing but minus 1. So yp is nothing but 4 cos x plus 3 sin x divided by d square is nothing but here minus a square. We have to substitute in this case. D square equal to minus a square. Minus a square is nothing but minus 1. If we take d square equal to minus a square, minus 1 plus 4 become 3. So numerator is same, that is q of x 4 cos x plus 3 sin x by 4d plus 3. And take the rationalizing. What is 4d plus 3 rationalizing? Take the change sign. If it is plus, we have to take minus. So 4d minus 3 by 4d minus 3. Take the rationalizing factor of 4d plus 3, that is 4d minus 3. Multiply and divide with 4d minus 3 here. So numerator I am writing 4d minus 3. In the denominator I am writing 4d minus 3 into q of x. What is q of x here? 4 cos x plus 3 sin x divided by 4d plus 3. Now in the denominator we have a plus b into a minus b form. So already we know what is a plus b into a minus b. A square minus b square form. Numerator is same. I am not disturbing anything in the numerator. Now go for the denominator. A minus b into a plus b form here. So a minus b into a plus b is nothing but a square minus b square. What is a square here? 16d square minus a square. A square minus b square. B square is nothing but 3 square, that is 9. So 16d square minus 9. Again, which is the d square form. So we have to change 4d plus 3 into again d square form by taking rationalizing factor. What is the rationalizing factor of 4d plus 3? 4d minus 3. So multiply and divide with 4d minus 3. That will change into d square form. Whatever the problem and whatever denominator here, our intention is only to replace in place of d square minus a square. So here in the first step we have only d. So in place of d we cannot replace minus a square value. So if we want to replace d square equal to minus a square, in the denominator should be d square form. So go for next slide. So here also denominator 16d square minus 9. This is also same, like in place of d squared we can substitute as it is minus 1. So put d square equal to minus 1 in the denominator. We have changed the denominator d into d square. So we can replace in place of d square minus a square. So if we take d square equal to minus a square, minus 16 minus 9, nothing but which is minus 25. Denominator is completed. Now go for the numerator. In the numerator we have 4d minus 3. Already we know d is nothing but d by dx. What is d by dx? D is nothing but differentiation with respect to x. So multiply 4d into this total term minus 3 into this total term. D nothing but differentiation. Also already we know differentiation of cos and differentiation of sin. What is differentiation of cos? Differentiation of cos is minus sin and differentiation of sin is cos x. So 4d into 4 cos x minus 16 sin x. 4d into sin x. Differentiation of sin become cos x. 4 3s are 12. And next one 4 3s are 12 cos x plus into minus minus 3 3s are 9 sin x divided by minus 25. Now simplify this. We have minus 25 sin x by minus 25. Both numerator and denominator will cancel and we'll get only sin x. So if we take d square equal to minus 1 in the denominator, we have only constant term in the denominator, that is minus 25, and multiply numerator 4d into q of x term and minus 3 into q of x term. So after simplification, both the terms are same, like sin x and cos x. Simplify a corresponding terms, we'll get minus 25 sin x by minus 25. Minus 25 and minus 25 will cancel and we'll get only sin x. So now the general solution of y equal to yc plus yp. Yc is nothing but complementary function and yp is nothing but particular integral. Already we find yc by using roots. Here we got roots are real and the same repeated roots. So yc is nothing but c1 plus c2x into e power minus 2x, and yp is nothing but from this we got sin x. This is the general solution of the given differential equation f of d into y equal to q of x. But in this problem, given initial conditions are there. What are the initial conditions? Y dash of 0 equal to 0. And for this, and y of 0 equal to 0. What is the meaning of y of 0 equal to 0? You can compare this y of x equal to y of x naught equal to y naught form. Substitute in place of x 0 and left hand side y become 0. in the equation 1, substitute in place of x is 0 right hand side and left hand side, y naught also become 0. If we take 0, e power 0 is 1. So c1 plus c2 x becomes 0. So we have only c1 plus sin 0 is 0. So we have c1 become 0. Substitute in place of x 0 and y 0 in the equation 1. We have RHS term becomes C1 and LHS we got only 0. So therefore we got C1 equal to 0. Now one more condition here we have, that is y dash of 0 equal to 0. So what about y dash of 0? Derivation of y. So first take the derivation of y. What is the derivation of this? C1 plus C2x into uv you can take. Differentiation of uv is nothing but uv dash plus v u dash. Take c1 plus c2x totally u and e power minus 2x is v. What is uv here? U into v dash plus v into u dash. And to take the differentiation we get equation 2. Now given condition is y dash of 0 equal to 0. What is the meaning of here also? Y dash of x naught equal to y naught. Substitute in place of x 0 and take y 0 in the equation 2. Then from equation 2 we got 2c1 plus c2 plus 1 equal to 0. So by substituting c1 in this we get c2 equal to minus 1. Already we have c1 0. Substitute in place of c1 0. Then we will get c2 equal to minus 1. So in any problem, if we have initial conditions, means we have to replace c1 c2 with the constants. So by using these two conditions, y dash of 0 equal to 0 and y of 0 equal to 0. In these two conditions, we have to eliminate c1 c2 with c1 0 and c2 minus 1. Now the required solution is y equal to minus x into e power minus 2x plus sin x. So this is the complete and the general solution of the given differential equation with the initial boundary values. Hope you all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.